and welcome to our very first episode of Research Done Right with your host, Wonder Woman. For our very first lesson today, we're going to be talking about the scientific understanding of behavior. On our agenda today, we're going to begin by learning about the definition and the true understanding of what the field of research methods is all about, and more importantly, why we should care about it. Why is this field so important to psychologists, sociologists, researchers in general? Following that discussion, we're also going to talk about different sources of knowledge. In other words, where do we get our knowledge and how do we learn about things? So if you're thinking that most of our knowledge comes from experiences, you're absolutely right. But we also have things like intuition, and we also have members of authority that try to tell us right from wrong. Last but not least, we're going to talk about my favorite and most proper and objective source of knowledge, which is the scientific method. After we spend some time learning about the scientific method, we'll also try to understand the specific goals of scientific research and why we conduct that type of research in the first place. And we'll wrap up our discussion by talking about the different types of research that exists that as scientists we may come across. So let's get started. What is research methods and why is it important? Well, research methods help us understand the world around us. Research methods also assist us in making correct decisions. They create a possibility for us to evaluate behavior, cognition, people's thoughts, as well as our emotions. And the way that we do this is using an objective and empirical approach to validate hypotheses that scientists may have. In other words, in order to prove something or disprove it, we can't just use our opinions or some sort of subjective ratings. We have to collect evidence. And this evidence leads us to an empirical decision, which we will then use to determine whether our hypothesis, our guess, our assumption for the relationship between two different things is right or is wrong. In other words, is it happening because we can truly test and manipulate a relationship, or is it happening out of sheer coincidence and by chance? So research methods help us identify how to make a decision about our hypothesis. Research methods also help scientists compare and critique research of each other among other scientists in the field. So what good is research at all if you can't share it with others? Everyone in the world of psychology, sociology, biology, many different fields utilize research methods. This course is designed specifically for psychology scientists and psychology research. However, these factors about research methods apply to any field and any domain. So imagine that you are a scientist and you've conducted some type of research. You definitely would want to share this knowledge and share it with your colleagues, with your other scientists who are interested to hear what you have to say. So oftentimes this type of research is published in peer-reviewed journals, in databases. It's available to a variety of students, such as yourself. So if we can understand and identify what is affecting a behavior, a thought, or emotion, then we are able to manipulate those stimuli and achieve desired outcomes. So before we start learning about exactly how to achieve those desired outcomes, let's talk a little bit about the different sources of knowledge that exist when it comes to even thinking of a possible research question. So how do you typically develop your opinions, ideas, and judgments? Where in fact does knowledge even come from? Well, oftentimes we say that experience is knowledge, right? Experience is the main source of knowledge. If you experience it for yourself, you could say that you have learned it, you have gone through it, you know what it felt like, you know what it tasted like, so on and so forth. But sometimes if you didn't experience it, you are kind of obtaining your information from a third party, from someone else. And this someone else can be your parent, your friend, a celebrity, a politician, someone you look up to, someone you don't look up to, etc. So even if we are not the ones to experience something firsthand, we're still able to absorb knowledge from other sources. However, one of the sources is within us, and this source of knowledge is called intuition. So oftentimes we hear mothers say that they have a maternal or mother's intuition when your mom kind of knows that something is wrong without you even telling her, right? It's a feeling, it's a sensation. And sometimes, you may not know what is right or wrong. You may not know the correct decision to make, but you have a gut feeling, right? So this is often called intuition. And sometimes, most times, if we have no other source of knowledge to rely on, we often go with our intuition to help us make our decisions. So basically, we're accepting information based on our own personal judgment, and sometimes even based on someone else's experience. And if you're thinking to yourself that is a great way to conduct research, you're probably a little bit wrong. And if you're thinking, well, using only intuition is a really, really subjective measurement for making a decision in terms of research, then you're absolutely right. So it is a problem to base any sort of research scientific findings strictly on your intuition or what you feel like should be the answer. Our perceptions are affected by several cognitive and motivational biases, which cause us to draw certain conclusions. Sometimes we favor certain choices and we don't favor others because sometimes they're in our benefit. Sometimes something may seem more familiar to us, so we feel like that's the better choice. So there are a variety of different things that bias and influence our objective thinking to make us think in a much more subjective manner. And so these are not good examples for how we should be conducting scientific research. Another example of when we draw conclusions based on observations or things that we have experienced is, for example, a stereotype. So a stereotype, I won't get into those with you here, but I'm sure many of you, if you just think a little bit very quickly, I'm sure that you can come up with a variety of different stereotypes. So a stereotype is an example of a poor source of knowledge. Why? Because it often leads to what is called illusory correlation. So if we think about the word illusory, it reminds us of the word illusion, right? Something that is not real. And the word correlation, if you remember from your statistics class, is another word for relationship. So if it is an illusory correlation, that means that you are imagining a relationship between two things that in fact are not related in any way whatsoever. So you've probably heard this a lot, that correlation does not equal causation. Just because you see two things co-occurring at the same time does not necessarily mean that one is causing the other to occur. So that is another example of something to be wary of whenever you're conducting your own scientific research. Remember, conclusions cannot be drawn based on someone else's opinion or an experience that you or someone else had one or two times in your life. Scientific research has to be yielded by evidence, and those conclusions need to be drawn based on multiple observations validated by statistical analyses in order to finally conclude whether the relationships or the correlation between two things that we see are not due to chance, are not due to coincidence, but in fact to true causal reasons. Another source of knowledge that we're going to talk about is authority. If we use authority as a source of knowledge, it means that we are accepting information to be true based on the rank or the status of the person giving that information. As Aristotle once said, persuasion is achieved by the speaker's personal character when the speech is so spoken as to make us think him credible. We believe good men more readily than others. So in other words, what Aristotle is trying to say here is that if you are listening to someone that you typically respect and look up to, and this person is of a higher rank or a higher status, and they speak in a confident manner, and we believe this person to be righteous and true, then the chances of us believing what he or she is saying will be much higher. So basically what this means is that we are willing to accept what people say as truth if they are confident when they are speaking it. We're more willing to accept something as truth without testing it or validating it with any type of evidence or hypothesis testing, just because we look up to and respect this particular figure of authority. So who could be figures of authority when it comes to our lives? As I mentioned before, these could be parents, these could be religious figures, these could be celebrities, or even a member of the Justice League. However, even if you're talking to someone who sound like they know what they're talking about and they are a good person, there is still a problem with this because this figure of authority doesn't provide an objective point of view and lacks evidence. Now, if you're saying that you have read a scientific article in a peer-reviewed journal written by some PhD who has provided extensive information on the methodology he or she used with actual evidence, then that is a completely different story. What we are saying here is that you don't want to just believe what someone says without having any information to back it up. Okay, so you're probably thinking, Wonder Woman, you told me about all the things I shouldn't do. So what is the solution? Which source of knowledge should I actually go with when it comes to research methods? Well, the solution is you have to conduct the research yourself. If we want to prove a particular hypothesis true or disprove it, if we want to actually make a statement and validate it and show that it is in fact true, then what we need to do is collect evidence. We need to be able to have a way to present our research in an objective manner in order to show that we have significant amounts of evidence to back up our statements. So, how do we do this? The answer is in 3 words: the scientific method. You probably learned about the scientific method back in grade school and heard about it again when you were in middle school and probably out throughout high school. And if you think about it, the scientific method, it is a very, very common procedure if you dissect it and you realize that maybe even you use it every day. So let's take a closer look at the scientific method. So if we start at the top, the scientific method typically starts from a question. Now, this question is what we call the research question that the scientist has in mind. We start thinking about the scientific method when we have a particular research question, when we have a hunch that 2 things seem to be related, but we need to be sure and we need to test it and we need to collect evidence to validate our particular hunch. So the very first thing that a researcher needs to do is identify their research question. Now, this is often the hardest part in the scientific method because you have to think of a question that is specific enough that it can be tested. A lot of times we have very vague questions and we have hunches, we have some sort of like intuition about how we think 2 things may be related or 2 or more things could be related. But in order to test it, you have to think about what is a realistic, specific enough type of question that will be able to give you statistical and quantitative measurable results. So the research question is often the hardest step of this entire process. Once you have narrowed down your research question, the very first thing you want to do is look up what other type of research has been done on this specific question. If you find extensive research has been done on this topic, then it's very wise to read what other scientists before you had to say. It's possible that you will find research that supports your hypothesis, but it's also possible that you will find research that refutes your hypothesis, and that's absolutely okay. The whole purpose of what we call the literature review is for you to understand what other work has been done on this same topic. For example, if you are interested in finding information about a topic that's very popular or very common, you're more likely to find various sides of the spectrum as far as supporting or refuting your hypothesis. You also have to understand that times are changing and people are evolving. So even the concept that is relevant today could have been relevant 10 or 20 years ago, and the results may have been different. So oftentimes researchers or scientists, they're interested to see how certain results of the same topic have changed over time. So they may want to ask the same research question but have a different hypothesis that would yield different results. So the literature review is the very first thing you want to do after you've established your research question. Using this previous literature, it will help you identify a specific hypothesis, which brings us to step 3. A hypothesis is your prediction. It is this educated guess about how you think the results of your study, of your experiment, will play out. This is where you start to think about the relationship of the independent variable and the dependent variable, right? Your hypothesis should be very, very specific, and you should also think about alternative hypotheses. So you should have, and if you have a variety of different variables involved in your research project, then you definitely want to have more than one hypothesis. So I typically like to think of the rule as many independent variables and dependent variables you have, that should indicate the number of hypotheses that you're going to be coming up with. So remember, the more variables you have, the more specific hypotheses you will want to come up with. All right, so let's say you have your hypotheses nailed down. You know exactly what you're going to be measuring. You know how you're going to be measuring it. Now you start crafting your experiment. So the experiment typically is going to involve a very specific breakdown of your procedure. Why do we need a very specific breakdown of this procedure? Well, remember when I told you that research methods, one of the key factors in research methods is that we can allow others to compare and critique our research. The way that they could do that is by reading our methodology. Other scientists and readers and students and anybody who becomes exposed to your research should be able to replicate exactly what you did as the scientist. This removes all the shade, right? It's showing, hey, this is what I did, and if you want, please be my guest and replicate it, and then see if you get the same results that I did. So in this experimental phase, when you're preparing your materials, it's very, very important to be as specific as possible and explain how you created your stimuli, what you used to measure, if you used a scale, if you used a survey, so on and so forth. So as much detail as possible should be included in the materials and methodology section. All right, so let's say you have your materials and you know which methods you're using, you have your procedure squared away. Then you actually conduct your experiment on real participants. You're in the stage of gathering data. Okay, so data is basically your evidence. Data is a very, very important part of the scientific method. Data is going to be the objective measure. So none of the quantitative data that you are collecting is going to be subjective or based on your opinions. No, they're going to be based on scientific measurements or information that is coming from the participants themselves. And then you, as the researcher or the scientist, are going to make heads and tails of all of these numbers and all of this information that you've collected. But the point is that you must collect this information. Sometimes you don't actually collect quantitative or numeric information. Perhaps you are going to go into the field, into like a natural setting, and just observe people in their natural habitat. Perhaps you are doing an experiment in which you're not knowingly giving the participants any type of stimuli, because that may make them behave or misbehave a certain way, knowing that they're being watched or that they're under some type of experiment. So sometimes you just observe people in the field. So you, instead of collecting data quantitatively, you could use observational data. But again, observations are a little bit less objective because they are based on what you saw or what you perceived, right? Seeing and perceiving are a little bit different. So oftentimes if you're doing any type of like field research or collecting data in a way that's not quantitative or statistically analyzed, you kind of want to do it with more than one person so that you have another opinion. All right, so far we've conducted our experiment, we've collected our data, we talked about our observations, what we saw. Now we have to put it all together. We have to draw some conclusions from all of this data. So if you are collecting data using numbers, right, in a quantifiable way, we use statistics to find significance between variables. And if you want a little flashback back to your statistics class, whenever you run an analysis, if your significance value is less than 0.05 or 5% error, that means that you do have significant findings and there are significant effects between your two or more variables. However, if your significance is greater than 0.05, that means there was more than a 5% chance that you could be wrong, and therefore you do not have statistical significance. In other situations, if you are not using statistical analyses, there are other ways that you can make inferences or draw conclusions, but again, that makes them less objective. So the best way to reach an objective and strong empirical conclusion is by doing statistical analyses. So let's say you have come to a certain amount of conclusions and now you need to decide, was your hypothesis correct or was it incorrect? Did you find statistical significance to validate your hypothesis or did it refute your hypothesis? The most important thing to note here, and something that people often confuse or misunderstand, if you do not have significant results, that doesn't mean that your experiment was bad. That doesn't mean that you did something wrong. Having a non-significant experiment is just as important as having significant findings in your experiment. Because again, based on the non-significant findings, you can then go back, reformat your question, maybe realize something based on the conclusions, based on the things you saw, that maybe the way you formatted your question was incorrect. Or maybe now you have a completely different question altogether. So all research is useful research, okay? It doesn't always need to be statistically significant in order for it to be viewed as useful. And so once you get to this conclusion part and you're motivated and inspired to ask more research questions, then you start the cycle all over again. So as a recap, the scientific method is used in all fields of science, not only social or behavioral science. After some sort of intuition or authoritarian statement, scientists try to prove theories based on empirical scientific evidence and what is called skepticism. So skepticism is the idea that things are not considered to be true until they are proven true using some type of scientific investigation. In other words, skepticism says that ideas must be evaluated on the basis of logic and evidence or results from science. Once those scientific investigations come back with results, then we can say that they were empirically tested. And so empiricism is the idea that knowledge is based on observations. So in other words, we remain skeptical for as long as it takes until we can empirically prove or disprove something. So this brings us to the different characteristics of the scientific method or the scientific approach. So previously I mentioned to you using statistics to analyze quantitative measurements. I also mentioned that not all research is going to be done using measurements of numbers. Sometimes we actually go into the field and we make observations. Sometimes variables are not quantitative, but they are qualitative. So for example, if we're looking at a behavior, we can identify it as a good behavior or a bad behavior, positive or negative. Regardless of the type of variable, it's very common that we code categorical or qualitative variables in which we assign a number to a word or a category in order for it to be easier for us to keep track and record this information. So this information that I speak of, we're going to call data, right? And data play a central role in the scientific method because they are the core of empirical evidence. They are the evidence. And for this reason, all observations must be coded, recorded, and analyzed for comparisons. Secondly, scientists are able to replicate studies. So going back to the whole purpose for why we have very specific instructions and format when we report methodologies and the materials used, this is mainly so that other scientists have a clear way to replicate the study should they want to. The third characteristic of this approach is falsifiability, disproving a hypothesis after it is proven true. So imagine that you are a scientist and you have a particular inkling, you have a hunch that two variables are related in some way, but all of the research that you found says that they're related in one way, and your hypothesis is that they're related in a completely different way. So hypotheses that have been proven true over and over, you can still replicate that study and try to prove your hypothesis, which is true to you, but would disprove the previous research. And so falsifiability is another key characteristic of the scientific method. And last but not least, scientific evidence is peer-reviewed and recommended for publication. Remember, what is the point of conducting all of this glorious research if other people can't read about it or learn about it? So for that reason, scientists have collaborated, and we have now created a variety of different journals. But in order for your research article to be published in such a journal, it has to be peer-reviewed. So peers are other scientists in your field, and different journals have different criteria for how many peer reviewers they have. However, you can never get your article submitted in a prestigious journal if it wasn't reviewed by other scientists such as yourself. And again, this is done strictly for the protection of all of science, so that everyone is reading true, valid research and not someone just trying to, spread false information or misrepresent real data. So the next thing we're going to talk about are the different goals of behavioral science. Remember when we said that research methods applies to a variety of different fields? A lot of times when it comes to the law or various types of crimes, psychology plays a big role. So when police or the authorities are looking for evidence, they will turn to things like asking specific research questions. So in a particular accident, for example, one of those questions could be, how fast were the cars going when they collided? The second goal of behavioral science is to predict behavior. So if watching movies about superheroes increases your willingness to do good deeds, would you expect to see more kindness in the world after watching Wonder Woman? If we're able to understand cause and effect relationships between people or their behaviors, we can then use those behaviors, be observant and vigilant when those types of behaviors occur, and perhaps prevent bad things from happening, right? The more knowledge we have, the better we are able to describe certain behaviors, the better we're going to be able to predict what that person may do or may not do next. And so as I just mentioned, one really big goal of behavioral science is to determine causes of behavior. Previously, we said that correlation does not equal causation, that just because two things seem to occur at the same time but are unrelated does not mean that one is causing the other. So how do we determine that things are in fact sharing a cause and effect relationship? Well, causation is based on the following things. The first one is temporal precedence. Temporal precedence refers to the time at which events occurred. So what were the events that occurred and in what order? The second way that we determine causation is based on covariation of cause and effect. If we're looking at the relationship between two variables, let's say the cause is the independent variable and the effect is the dependent variable, we need to see when the cause is present, does the effect occur? And when the cause is not present, does the effect not occur? In other words, based on observations and data collection and our manipulation of that cause being present or absent, we can then measure how it affects the dependent variable or the effect in this situation. The third factor of how we can determine causation is alternative explanations. So a lot of times when we come up with a particular research question, we already have a specific hypothesis in mind. We have an educated guess for how the independent variable affects the dependent variable. But what are the other possible explanations for things that could be causing the dependent variable? What is an alternative explanation? What is something else that could be playing a role? For example, imagine that you go to the grocery store and the person in front of you is being very rude to the cashier, and the cashier happens to be wearing a red shirt. And then someone else walks by who also happens to be wearing a red shirt, and this customer that's in front of you is rude to them too. You start to develop this hypothesis that, wow, this person is being mean to everybody wearing a red shirt. So for sure, this person doesn't like the color red or is irritated by red shirts. Red shirts equals angry behavior from the customer. So based on our observation, that's a possibility. We're not saying it's truth yet because it only happened, in 2 instances. However, what are some other possible explanations that could be causing the customer to behave this way? Perhaps the person had a really bad day. Perhaps the person was in line for a very long time. Perhaps everyone working in that store that was giving this person a hard time has a red uniform, right? So there could be a variety of different factors that could be causing a person to behave a certain way, but we feel like we can identify the reason just based on this observation of these 2 instances and interactions that we saw this person have. So temporal precedence, covariation of cause and effect, and alternative explanations are the 3 factors that help us determine causation. For example, studies showed that men found certain women to be more attractive because they wore red. And the 4th goal of behavioral science is to understand or explain behavior. Why is it that red makes someone look more attractive to a viewer? So let's recap the 4 goals of behavioral science. Number 1, to describe behavior. Number 2, to predict behavior. Number 3, to determine the causes of that behavior. And number 4, to explain that behavior. So those are the 4 goals of behavioral science. Now, as promised, to wrap up our talk, let's talk about the different types of research that you may encounter as a scientist in the world of research. The first type of research we have is called basic research. And basic research answers fundamental questions about the nature of our behavior. Basic research is often designed to address issues such as cognition, motivation, neuropsychology, learning, and social behavior. On a more specific and applicable approach to research, we have what is called applied research. Applied research is conducted to address issues in which there are practical problems and potential solutions. So this is a much more tactical, applied form of research, whereas basic research is much more foundational and exploratory. And related to applied research, we also have what is called program evaluation. Program evaluations assess social reforms and innovations that may occur in the government, in the educational system, in the criminal justice system, healthcare, mental health institutions, etc. So when we talk about program, we're talking about an organization or some type of initiative that exists as part of a larger organization. So the 3 types of research, we have our basic research, applied research, and program evaluation as a type of applied research. So now it's your turn to test your knowledge in terms of the different types of research. So your job is to state whether each research question that I'm about to show you should be considered basic or applied. So even if it's program evaluation, we'll still call it applied. All right, the first one is extroversion related to sensation seeking? So in order to figure out if this is basic or applied, you should first ask yourself, is this trying to answer a specific question? Is this asking me about a specific initiative? Is it asking me about a specific way to solve a problem? If you answered no to all of those, then your best bet is that it is a basic research question because it's much more foundational and exploratory. Let's look at the second one. Do video games such as Grand Theft Auto increase aggression among children and young adults? So once again, are we talking about something specific here or something generic? To me, it seems like Grand Theft Auto is a specific video game So I'm going to say that this one is applied. All right, the third one, how do neurons generate neurotransmitters? Once again, do you feel like this is generic, kind of a much more wide range of possibility of research questions that this could be answering? Or do you feel like this has a very specific intent and a specific problem that it's trying to solve? Number 4, does memory process visual images and sound simultaneously? Does this seem applied or basic? I don't know. I'll reveal the answers in a moment. All right, number 5. How can a city increase recycling by residents? So again, is this a general question or are we talking about a specific initiative? And the last one, which strategies are best for coping with natural disasters? Does this sound like a specific question, a specific problem looking for a specific solution, or does this seem something more foundational? All right, so hopefully you were following along and jotting down your answers as we were going through them. And so I'm going to reveal the answers to you. All right. So number 1, is extroversion related to sensation seeking? That is basic. Do video games such as Grand Theft Auto increase aggression among children and young adults? That is applied because again, we have this specification about a specific video game. How do neurons generate neurotransmitters? Again, very, very exploratory, very foundational, very vast type of a question. That's definitely basic. Does memory process visual images and sound simultaneously? Also a basic question. Remember, one of the bullet points describing basic research is that it often deals with motivation, cognition, etc. How can a city increase recycling by its residents? That's definitely applied because we're talking about a specific group of people living in a city, and we're talking about a specific program, recycling. So in fact, that would even be program evaluation, which lives under the applied research umbrella. And last but not least, which strategies are best for coping with natural disasters? Again, coping and natural disaster should give you the idea that this is very much applied because it's related to a specific research question. There is a specific problem that is in need of a solution, right? Coping. How do we cope when there is a natural disaster? That brings us to the end of today's lecture. I hope that you enjoyed that. I hope that you learned something. Thank you so much for watching, and remember to maintain your skepticism and practice empiricism. And I'll see you next time on Research Done Right.